So here's another important type of sequence that we're going to see more than the arithmetic anyway. This one's called geometric sequence. So in the geometric sequence, as we're going to see, every pair of consecutive terms has the same ratio. So let's look at an example of this to get started, and then look at a general formula. So to start with, 2 negative 2/3, 2/9, negative 2/27, 2/81, and so on. You could probably pick up the pattern if you need to. It's down here we have powers of 3, 3 squared, 3 cubed, 3 to the 4th. Upstairs it's, well, 2, negative 2, 2, negative 2, 2, negative 2. They're alternating back and forth just between 2 and negative 2. If we look at the ratio between these two, let's look at A2 over A1. That's my A1, A2, A3, and so on. A2 over A1 is negative 2/3 over 2. The 2's cancel, and that gives me negative 1/3. I'm going to do this again just to show you. You can do it with any of them, but if I do A3 over A2, the ratio is 2/9 over negative 2/3 gives me negative 1/3. Again, the 2's cancel and the 3 cancels with, or the 9 cancels with the 3, leaving the 3 in the denominator, and it's negative. So negative 1/3. So that's the ratio between consecutive terms. Now what I can do is, to get consecutive terms from a beginning term, well, my A1, and this is going to be my recursion again, with 2 R's, 3 R's. A1 is 2. And if I want AN, I can get it by multiplying AN minus 1 times negative 1/3. So let's go down the line doing that with this. 2 times negative 1/3 is negative 2/3. Times negative 1/3 is positive 2/9. Times negative 1/3 is negative 2/27. Times negative 1/3 is positive 2/81. But yeah, this recursion, if I give a starting term and then a way to get the consecutive terms, this is the recursion formula. Now, for a closed formula, or just a formula for the nth term, think about how we could get that. If we know what n is and we want to know what an is, well, think about what I do to get from term to the next. I multiply by negative 1/3. It's that same ratio from each. Just multiplying to get the next one. I'm starting though with a 2, and then I want to raise that ratio to the first power for this one. That's 2 times negative 1/3, or 2 times negative 1/3 times negative 1/3. Negative 1/3 squared. This one, 2 times negative 1/3, negative 1/3, negative 1/3. That's negative 1/3 to the third. The exponent that I need here for the fourth term, I needed negative 1/3 to the third. For the for the third term, I needed negative 1/3 to the second. It's 1 lower than the index of the term. So the first one has no negative 1/3 factor. The second one has 1. And what that amounts to is the exponent on negative 1/3 is 1 less than the index. I'm not sure if you can get there directly from this, but this is the closed form or the formula for the sequence. Now, I want to summarize a little bit the geometric and the arithmetic sequences before we go on to look at some limits.